Let's take a look at lecture example number 14. So lecture example 14 asks how many molecules of NH3, so NH3, ammonia, are present in 45.2 grams of ammonia. So we have 45.2 grams of ammonia, and we want to figure out how many molecules that would be. So I can convert grams to moles, and then I'm going to have to convert moles to molecules because grams does not connect directly to molecules. So 45.2 grams of NH3, we take that times, and first thing we want is moles. So it's 1 mole, and that's going to be over, what is the mass of NH3? It'd be something like, so what is it, 3 times 1.008 for the hydrogen part plus 14.01, and so that's going to come out to be times 1.08 plus 14.01, we get 17.034 grams for every 1 mole of ammonia. So 17.034 grams. So grams is going to then divide away. Now I could stop, find my number of moles, and then do the next step, but I'm just going to connect it in one long chain of dimensional analysis. So we got 45.2 grams times 1 mole over 17.03. That's going to leave us with moles. Now I need to get rid of moles. My goal is to have number of molecules. So then we need mole to cancel again. So it's going to be 1 mole is equal to 6.02 times 10 to the 23rd molecules. Moles divides away, and so then we can punch that into a calculator. Now to estimate, 45.2 divided by 17, so that's going to come out to be about 3, and then 3 times 6.02, so we're looking for a number in the neighborhood of about 1.8 times 10 to the 24th. So we can punch it into the calculator. So 45.2 times 6.02 times 10 to the 23rd. And then we're going to divide that by 17.034. And we get 1.5974 times 10 to the 24th. Now, in terms of significant figures, you're going to want to go back and look. So that has 5, that's a ton. You got 45.2 there, so that's 3 significant figures. So we need to round our answer to also be 3 significant figures. 7 is going to round our 9 up, and so 9 is going to then bump up. So our answer would be 1.60 times 10 to the 24th molecules of NH3. Now there's a little follow-up question here. The little follow-up question asks, how many total atoms would there be in 1.60 times 10 to the 24th molecules? Well, if we look at this, 1 molecule is made out of a nitrogen and 3 hydrogens. So that's 4 atoms per molecule. So I could set up another dimensional analysis problem. All right, so we're going to say 1.60 times 10 to the 24th molecules of NH3 times, and it is 4, and it's exactly 4 atoms for every 1 molecule. So molecule will divide away, and that leaves us with, what's that going to be, 6.4 3 sig figs, right? So 3. I wrote exactly 4 here because it's not a measured value. It's exactly 4. All right, so that's not going to limit our number of significant figures. So 6.40 times 10 to the 24th atoms. If we broke up that 1.60 times 10 to the 24th molecules of ammonia. So that's number 14.